So what they did, not necessarily just saying, well, how does that work? It was that they were saying, well, we think that speed is the upper bound velocity of the universe, and so we will just set up equations that do exactly that, and that's what they did. Well, I go into this a little later, but just because you come up with an equation doesn't mean it is relevant to reality. And that's the problem with a lot of the special theory. They came up with a bunch of equations that did nothing more than limit the speed of light as the upper bound. And they're not correct, they're incorrect. Right? So they used an assumption that was wrong to build equations and then build a theory, but the whole theory is wrong to begin with. What's the person's name? Gerber. I'm going back to the perihelion on Mercury. It was Gerber. Paul Gerber. Paul Gerber, a German mathematics teacher, came up with the first true equation for the correction of Mercury, the perihelion of Mercury. So, anyway. Okay. Yeah, however, the solution is questionable, right? In other words, if you add 0.8, let's say you're in this situation, you add 0.8 and 0.7, you know, one for the source, the actual source, and the other being going 0.7 respective of that, what you're going to end up with is a total speed of 0.96, right? So in other words, the formula, velocity addition formula, takes two velocities that would normally be 1.5 and just makes them into 0.96, less than the speed of light. And I'm saying that's wrong. That so it's mathematically inconsistent. And I remember writing to one of the physicists and saying, is that what you teach your children? 0.8 plus 0.7 equals 0.96? They never answered me. I guess they do. Okay, so it's 1.5, same thing here. While I was pondering whether or not acceleration should be a viable component in the special theory of relativity, I wrote a short logical sequence using ideas from just Newton and Einstein, which ended in the result that the special theory of relativity equals the general theory of relativity. So it's on, this is video number 7, the velocity addition equation, a tale of two theories, right? So I just worked it out. It was there for everybody to see. It was from Newton and Einstein only, and I just worked it through and came out to the end that the special theory of relativity equals the general theory of relativity. I think you can kind of read a lot into that, but at some point we have to get away from this. Here's the special theory of relativity, here's the general theory of relativity, and none that, you know, they should meet. That's not the universe. The universe is one whole, and so you have to come up, we have to move forward and to come up with one idea that sort of encapsulates all of that, because you can't have two separate theories, you know, depending on just a few equations that don't work. Okay. But the most relevant, we can, yep. There's no room for the two of them. Okay, so that's it. I mean, that's sort of basically what's in there. And still thinking about the perihelion of Mercury. Okay, so here's one, relativistic mass and Blomdahl's law. Relativistic mass is based on the Lorentz factor. As such, it states that when an object and or particle approach the speed of light, the mass will shoot up to infinity. This is completely incorrect because it's based on the Lorentz factor, right? The major aspect of the video is the introduction of Blomdahl's law. I wonder where that came from. Every physical system has an absolute operational and finite upper bound per period/unit time. Okay? This means that an object and or particle will reach its fixed operational limit and can go no faster or further at that time. It also means that although the inputs could be infinite, the output will always be fixed per period of time. Right? So what does this mean? Well, a race car is an example. Although the inputs, gas, tires, engine, driver, can be changed or upgraded, the top speed, say 200 miles an hour, is fixed, and the car can go no higher. In other words, a better grade of gasoline, no matter how great, will not allow the race car to go 1,000 miles an hour. Right? And you have the same idea with particle physics and accelerators, accelerators. No accelerator has ever broken the speed limit, right, or of light, right? It hasn't gone faster than c. It's like 0.9999999999997, of the speed of light, but it can't go faster than that. Well, I think what's happened based on that, using the accelerators that we have and so forth, you're never going to go beyond the speed of light. You're never going to break it. Why? Well, what makes the difference is technology, right? It is demonstrated graphically how technology continually pushes out the old upper bound for a given set of inputs. This will continue to happen in shorter and or longer leaps at different times. There are several examples given, such as aircraft, automobiles, even short or long distance runners, right? I mean, a lot of it has to do with, it's just technology, like propeller-driven aircraft, right, to jets, right? I mean, that's a major leap in technology. So if we want something to go faster, like an accelerator, the technology we have is not going to do it. It's not going to work. So we have to go do something beyond just accelerators to come to a to find something that's will go faster than the speed of light. I mean, it's it's there. It just may take a time to do that. So yeah, so technology is the one factor. Even in runners, I mean, you have better running shoes, better tracks. I mean, people run more or whatever. At one time, they were all considering, well, we'll never break the 4-minute mile. And then Roger Bannister back in 1952 broke the 4-minute mile. He did it like by a couple of seconds, but he did it. Nowadays, if you have several people running a mile, they'll all break the 4-minute mile, right? When one did it before, now 4 people do it. They all break the 1-minute mile, even the guy that comes in last. Same with technology, we sort of advance on that way. Okay, what is this? So that was video 8, relativistic mass and Blomdahl's law. Okay, 9, the time is up for space-time. Okay, since we were young, we thought we knew and understood time. But what we know is merely relative or pseudo-time, not absolute time, which does not exist. In other words, the universe does not know what time it is. Based on this understanding, time cannot be imbued or embedded into 3-dimensional space, whether the flat space of Minkowski or the curved space of Mr. Einstein. Right? Keep in mind, if space can't bend and time can't bend, then space-time can't bend either, right? So this idea of time, going back in time, going forward in time, I don't really see how it's possible. If time doesn't exist in the first place, I mean, it's there, the universe is there, but it has no understanding of what time is. What we use is this relative time or pseudo-time. But that has no meaning in the overall evolution of the universe. So, anyway, all right. No, I'll let it go. Progression of the perihelion. No. All right. 10. Thoughts on the STR and GTR, the special theory of relativity and the general theory of relativity. Appearance versus reality. This video shows that with both special and general theories, all aspects of these theories are appearance only. In other words, neither has anything to do with reality. As examples, with time dilation in the special theory, how would one's gallbladder or hair know to grow slower if the brain of the passenger cannot discern by any means that the craft were in motion or not, right? This would be magic, which is not applied to science or reality. If you can also think on your own about the problems inherent in the Lorentz-Fitzgerald contraction, right? So here you have the special theory of relativity. No experiment can be conducted that the person in the mind could understand or can discern whether the craft or whatever that they were in was in motion or not, right? So there's no signal, there's nothing there. So how is your gallbladder going to know how to slow down your hair or your toenails or whatever? I mean, how is that going to happen? It doesn't happen, right? It's not going to happen. It's wrong. With the GTR, how would the planets in our solar system stay in their orbits around the sun if there is no gravitational tether? Newton's third law of motion, right? In other words, with Newton, you have this gravitational tether between like the sun and Jupiter. In Einstein's curve, that you don't have that. There's nothing there. I mean, the only phenomenon that could hold a planet in its orbit around the sun would be a gravitational trough, right? That's sort of embedded in there. But you're not going to find that, right? There's nothing there. I mean, if the universe were actually based on Einstein's idea, the general theory, the whole universe would be flying up to pieces. It would just be flying all over the place, right? Right, okay, so here we get on to Blomdahl's axiom. Simply because one can write an equation doesn't mean that it has any relation to reality, right? It's like the dilation for, time dilation for the special theory, right? You can put numbers in there and you'll get a different number out of, a different solution. It doesn't mean it has that it's correct, that it has anything to do with reality. It's just an equation. And that's the trouble with a lot of these. There's nothing there. You can put numbers in it and whatnot, but there's no relevance to reality in there at all, right? That's a big problem. This is also expressed, mathematics is not a substitute for thinking, right? You have to be careful with mathematics. It can help sort of delineate your argument, but you can't rely on mathematics alone to make a theory that requires far more than that. So that's sort of the rundown. So that's number 10, thoughts on the STR and GTR. So that's sort of a rundown of what I did. I'm still trying to think about the Mercury precessions of, I can't think of it, my mind's blocked. But anyway, so Paul Gerber is the person you can look up. All right, so here's just some points that I wanted to raise as I'm sort of interacting with the scientific community, not only in the United States, but Canada, some in France, some in Germany and whatnot.